So our first problem is on linear programming. Yes? Have a sheet of paper. Using your graph paper, we'll need that. So you may want to take the notes in the setup in your notebook, and then the graphing will go on the graph paper that you should have picked up at the front. All right? So we're using linear programming to maximize profit. Let's read the problem first. You are printing t-shirts and sweatshirts to sell at the Polk County Food Festival and are working with the following constraints. You have at most 20 hours to make shirts. You want to spend no more than $600 on supplies. You want to have at least 50 items to sell. And then there's some information over on the shirts that we need to make sure we write down. So I want you to label this problem the t-shirt and sweatshirt problem in your notes, please. T-shirt and sweatshirt problem.
Can we do it on the back?
Well, you can, if that works for you. Yes. That'll get this a little out. All right. So then for one color t-shirt, it takes 10 minutes to make, and the supply costs $4, and the profit is $6. So I have a table down below that you want to make for yourself just to organize the information. So we have t-shirts, sweatshirts, and the total. What we are being asked to do in this problem is how many t-shirts and how many sweatshirts should we use or should we make to maximize your profit. Okay, so some little notes that we should make for ourselves. What are we solving for? Our solution will be telling us how many of what? Yep, we want the number of t-shirts and the number of sweatshirts. Okay, so let's call the number of t-shirts, let's get a nice easy variable for that. Let's say an x and y just to make life easy. We'll call the number of t-shirts x and the number of sweatshirts y. Okay, and how many? Do we know how many we want to make, or are we restricted on how many we make? You want to make at least 50 items to sell. We are restricted, and it will be restricted to be 50 or bigger, correct? At least, so 50 is the least. So 50 or more. So we would say greater than or equal to 50 in our total. Okay, so for t-shirts, it takes 10 minutes to make a t-shirt. All right. So for t-shirts, time to make, put 10. And for sweatshirts, how long does it take to make those? Can you see it? It takes 30 minutes to make sweatshirts. Are we restricted on time?
Yes.
Yes. What does it say?
20 hours.
At most 20 hours. So what's the inequality we would write there? Less than or equal to. Do I write 20?
Oh, it's not if I times it by 60.
Right. So 20 hours times 60 minutes per hour. 1,200 minutes. Okay, so do be careful about units when you are doing these problems. All right, supply cost for t-shirts. The supply cost for t-shirts is $4. And the supply cost for sweatshirt is $20. Is there a restriction on supplies? You want to spend no more than $600 on supplies. So what do we write? Less than or equal to. Very good. Okay. how much is the maximum profit. So we need to know how much profit we make on a t-shirt and how much profit we make on a sweatshirt. Profit for the t-shirt is $6. Profit for the sweatshirt is $20. Okay? So, this table was not given in this problem. I just made this table to organize the information. It will be helpful for you to organize the information in that way. So now, based on this table, we're going to write our constraints and our objective function. Can somebody raise their hand and give me one constraint? One constraint includes inequality.
X has to be greater than 0.
Oh, that's true. Definitely true. X has to be greater than or equal to 0. We're not going to make negative amounts of either t-shirts or sweatshirts. And graphically, what does that do for us?
Keeps us in the positive.
Good. Keep us in the first quadrant, so we don't even need to pay attention to the second, third, or fourth quadrant. We're just going to stay in the first quadrant. All right, now, how about constraints from the information we have in the box? Murder.
X plus y is greater than or equal to 0.
Very good. Okay, next one. Move down the line.
2.
Yep, 10x.
10x plus 30y.
1200. 10x plus 30y is less than or equal to 1200. And then finally our last constraint is 4x plus 20y will be less than or equal to 600. Okay? All right, so when you graph your constraints, you really have to graph x is greater than 0, y is greater than 0?
No.
Do not. You can just set up your graph so it's only the first quadrant, and that will take care of that. Okay? How about our objective function? Amber, how about that? We'll say P equals, based on the profit.
So, this
Plus 20, that's it. We're done. There's no less than or equal to there. It is the actual profit that we're trying to find out how to maximize. So this is the one we'll plug into, and these are the equations that we will graph. Equations, inequalities. Any questions on where these came from? All right, so you can tell the hardest part of linear programming problems is what we just did, separating all the information and understanding what they were doing.
Are you looking for the max in the objective function?
We are looking to maximize profit, yes. In this case, we're looking for the max. All right, everybody okay with this? And you have this in your notes so I can go off the screen, yes? Okay. All right, let's move on to your graph paper. So,
Is this how Nick Alford is doing this graph paper?
it is. All right. So I made each one of these 10, 20, 30, 40. Yeah. So I made every 2 boxes worth 10, so every box worth 5, but I marked each 2 boxes worth 10, so here's 30, 40, 50, 60, 70, 90, 110, 130, and so on. Okay? You have your ruler. You're going to use the whole page and set up your graph like this. And these, I think we just went,
Would you? Yeah.
these are, each one is worth 1, each box is worth 1, so that's 5, 10, 15, 20, 25, and 30. Now, I happen to know where this problem is going, so I made my graph based on that. For you, before you make your graph, I would say solve each of the inequalities for y. You can see what the y-intercepts are. Okay, so before you, when you do this on your own, before you set up your grid, solve the constraints for y.
Do you just put, I mean,
Yep, you do. So right now, that's what I want you to do. I want you to isolate y in all of our constraints. And before you start graphing on, let's make sure we all agree on this, so you don't have a mistake in your graph.
everyone,
Sorry?
what's the box?
Each box is 5. 4, 7, 16, 20, 25, yeah, each box. Now you're going to solve your inequalities for y. Thank you. Doesn't work. But
Because the y-intercept is 50 for 1.
let me look. It'll be okay. So which one is that?
It's the x plus y.
Yeah, do you have more room on yours? It'll be okay on mine, because I can make it go that far. That's all right. I'll show you what to do. Now, I did something funny here. In my first constraint, I'm leaving it y is less than or equal to negative 10 over 30x plus 40, just because that's going to be easier to count with my grid. So I just left it to negative 10 over 30. So we're getting each of these solved for y. For x plus 21 less than or equal to 600. There we go. So I have my constraints. All right, so we have our first line graph. We use x and y intercepts to graph it, and the shading would be below. We'll add the shading later. All right, how about this next one? X and y intercepts on this one, please. On inequality number 2, 50 is our y, and how about x?
50.
Also 50. And we change the color, I'll do this one in blue. So I have 50 here. I don't have 50 on my graph, but you do hopefully on yours. If not, we'll just go up. So it's a slope of -1. So if I go up 5, then I should go left 5. Each box is worth 5 here. I'll go up 5 again, and left 5 again. And we can draw on this line. And bring it all the way through your graph. And looking at that. The shading for that one is greater than or equal to -x plus 50. So where would the shading be for that one? We test it with a point. 0 is greater than or equal to 0 plus 50. Is 0 greater than 50? Is
No.
0 greater than
No.
50? No, it is not. So where 0, 0 is the false side. So now we're looking at between these two lines. And our final graph, which I'll label number 3. Green. All right, so this one we should be able to graph pretty easily. If we did x and y intercepts for number 3, let y equals 0 to get the x-intercept. 4x equals 600. What's 600 divided by 4?
Are you? No, not.
600 divided by 2 is what? 300 divided by 2 again. There you go. So the x-intercept is 150, which is out here, 30, 40, 50, mine would be out here. And the y-intercept is what?
30.
30, which is here. I'll try to do a little more of that. So 30 and now we're like 20. Like that. So let me draw that one in. There is our third line. And now we need to identify our corners. So where would this one be shaded? Y is less than or equal to -4/20 x plus 30. If we test 0, 0, we get a true statement, so we're shaded below. So our shading, I'll do it in yellow, is under the first one, to the right of the second one, and under the third. So we're talking about this section. Okay? Yes? How did you get for this one, anytime you need an x-intercept, you put 0 in for y. So if I put 0 in for y, we get x equals 50. And if I put 0 in for x, I get y equals 50. So for that one, it's 50/50. And so I started here for my x-intercept. I don't have 50 on my graph, so I have to go up, equivalent to 1/1. So I went up 10 and over 10. It just looks different on the two scales. Make sure I did it right. Yep, up 10 is up to there, and left 10 is to that. Not much. Okay, so I think I'm okay. So you guys please circle the corners on your feasible region now.
Are there always 4?
No. There's no limit on how many there can be. All right, so let's take a minute, and I'm going to walk around. Let's see if everybody has the same vertices for our feasible region, and then we'll list them up here in 4 corners. We have our 4 vertices here, and now what do we do with them?
What am I doing with your
Plug them into the objective function. So we want to plug them into the profit where this is your X and this is your Y. So take a minute and do that. You can do it on the back. I'm going to move to a new screen and copy them down. So A was 75.15. B was 120.0. C was 50.0. And D, I think it's 25.25. Alright, these are the values that I get. So, at what corner or vertex do we get a maximum profit? 75.50. So what does that mean with respect to the problem? So we should make 75 t-shirts and 15 sweatshirts to maximize profit. Okay? Long problem. Be careful with your graphing. And your assignment then is 3 problems. Page 161, I'll write it bigger. 13, 16, and 18. And one of them is very similar to the cooking problem that we did in the packet on Friday. Okay? So you're trying to get started? Ask me if you have questions, please.
All right, so I did go back and my green line was slightly off, so I did make it so we can see the intersection at 75.15. Then we go and plug our corner points or our vertices into our objective function.